So in this video, I'm going to show you the programming version of the Robo Rally board game, and there is an assignment that goes along this, a project that goes along with this for some points. So there's a bunch of files that we're going to use, and we need to download all of them. So I'm in the folder that is linked to through your points spreadsheet. I'm going to select all these files. If I just click on the first one, then hold Shift, and then click on the last one, it'll select them all. If I go over here and press the three dots, I can click on Download and begin my download. So in the lower left here, it got partially cut off by the screen. I apologize for that. You can click and go to Show in Folder to show the downloaded file. So I've got it right here. Now, your Downloads folder is probably a lot more cluttered than mine is because you're using these shared computers. You need to move your downloaded file to your own personal folder. Maybe you go on the desktop and create a folder with your name on it. And the way I did that was I just right-clicked on the desktop and then I went to New and then New Folder. So if you do that and then open that folder up, now we can drag this file over to your personal folder. Oops. So now if I right-click on this file, make sure to right-click. You'll have all these options. You want to go to Extract All. Click on that, and then press Extract. You'll see a new folder showed up. Double-click on that one, and now you've got all your files here. We're going to click on Main. Main is going to be the main file that we want to run, but we'll actually be editing Robot Student primarily. But I'm going to start you off with Main and show you what we've got here. Okay, so here's our main file. There's a lot of code in here, and I'm going to hopefully show you what you need to pay attention to and what you can ignore. So I'm just going to go ahead and run this and show you what we got. So you'll see a Robo Rally board. This little blue guy is your robot. Now, I've just put in a very dumb program. All it does is move forward for my robot. It started over here, or it started right here, I think, and moved forward, and the conveyor moved it, you may have noticed. And then it moved all the way over here. Let's actually run it again so I can talk through this as it goes. So you see it moves forward, and we can slow it down, and I'll show you how to do that in a second. It runs into this wall, and then it can't move any further. There are 4 flags to collect. Here's the first red one, yellow, green, and blue. You can collect them in whatever order you want, but you need to collect all of them. And then these are holes in the floor that you can fall through. These tiles with the hammer and wrench are they're both checkpoints. So if you do fall off into a hole or fall off the map, you'll go back to your most recent checkpoint that you passed through. They can also repair you. We're not going to worry about the repairs too much. This green bar is your health bar. There's further places we can take this program where the robots actually like shoot lasers at each other and things. But for starters, we're not going to worry about that. We're going to worry about trying to collect all the flags. And there's different levels you can use as well. So I'm going to close out of here. And I'm going to show you a different level. So at the very top of main, or close to the top of main, which is where I'm at right now, there's a level number, and it's currently set at 2. And 2 is my most advanced level that I've created. If you change it to 1, you will see a simpler level show up when we run this. All right, so a very simple level, right? It's no obstacles, just the 4 flags to collect. This is a good test level. You'll notice my robot ran off the side and lost half its health. That's fine. It's going to keep doing that because it's not a very smart robot. All right, let's close that out. There's also a level 0. I think there's also a level -1 because I ended up wanting some more basic levels. Oh yeah, and this one's actually fairly complicated. I'll move that onto the center of the screen. Just testing out that I could put down these tiles. That's all I was doing on these. Now the other thing at the top that you might want to pay attention to is the frames per second. This is going to determine how fast your program goes. So if we make it 50, for example, this robot is going to go very, very fast. Right? It just zips right off the screen, and it's just going to keep doing that and keep falling off the screen. And if we want to slow it down to just 1 frame per second, we can do that as well. And now it's a little bit easier to see what your robot is choosing to do. You'll notice it prints out the movement that it's chosen, and it has other movements as well that it can do. And let's just see another move that the robot can do to show that it can print out other things. So for that, I'm going to need to open up Robot Student, which is my robot that I'm using. And there's a lot of comments in here, which I hope will help you understand this, but I'm going to talk through that in a moment. So movement, it says my next action equals move. Now, it also says self dot in front of that, and you may not have seen this before. This is something that you'll see more frequently toward the end of the course when we're dealing more with objects and classes, and we'll talk about what those are later on. I don't want to get into it for this video. The key thing to note is that there's a couple variables that the robot knows about that are going to have self dot in front of it. And next action is the most important one that you need to know about. And actually all the code that involves next action, there's already an example of it right here. You're going to write your code inside this choose action function, and it has to end with return self.nextAction, and that's already there, so you shouldn't change that. You should basically make some spaces in here, and when you get to the point where you're ready to write code, you're going to write it in this space right here. You're also going to change this line. This is just sort of a demo. So for right now, I'm going to change move to left to show you that the robot also has the capability of turning left. Now, when I want to go to run this project again, I don't want to just click run because I'm currently in the robot student file. I don't want to run robot student. I want to go back over here to main and run main. Like, here's what will happen if I run robot student. Nothing. Because robot student doesn't say, hey, create this board, put a robot on it, make the robot run around. That's what main says to do. So I'll go back over to main, and now I'll hit run, and now the board will pop up. And my robot will just turn left repeatedly. It's just going to spin in place. But that just shows you, hey, it's going to print out the movement that it chooses to do. And that'll help you determine if your robot is behaving the way that you think it should be behaving. So I'm going to close this out again. And now I'm going to show you some of the other actions that your robot can choose to do. If you want to see a list of those actions, you should open up robot. Please do not, however, change any of the code in this file. And there's a lot of code in this file. If you see how skinny the scroll bar is, you can see sort of how large this file is. It goes down to 405 lines of code. But somewhere in here is the word move, and I should search with it with Control F. If you've never used Control F before, it's very handy. Hold Control, press F, and then type in whatever word you want to search for, and it takes me right to the first instance of that word. So this is actually a do action function, which helps your robot perform its actions. And you'll see that your robot can turn left, it can turn right, it can move forward, it can zap. Now zap is where you would use this to shoot the other robots. Let's get into that later, where you have a competitive game. And that's it. Those are the things that your robot can do. Now, it can also sense its environment, and that we're going to deal with separately. But left, right, move, and zap are the things that it can do. So let's modify our student robot to choose a random action. And this isn't just good for demonstration. This might be something that you want to do periodically to help your robot, especially if it gets stuck somewhere. So I'm going to first go to the top of robot student, just verify that I did import random. Okay, import random. Great, I do have random, so that's fine. So then I'm going to go back into the choose action function, and notice I'm not modifying anything else here, right? I did put in some comments that you can read on your own, trying to explain what I'm doing, but I'm not going to go into the details of this until much later in the course. So it's not needed for this project. So suppose I just don't want to go left. I want to choose a random action from my list. So to do that, I'm going to create a list, and this might also be something new for you, but that's all right. So I'm going to call it action list, and I use square brackets right here to group things up in my list. Now this is just a variable name. I could call this X, I could call this whatever I wanted, but I'm just going to name it action list because it's going to be a list of actions. Then I use the equal sign to assign some values to it. Well, my options are left, comma, right, and notice these are strings, so I put them in quotation marks, move, and I'll put zap in just to show you what it does, and zap. Those are my actions that I can take, that my robot can take, and what I'm going to do next is I'm going to choose one randomly, and the way to do that is to say random.choice, and then some parentheses, and inside those parentheses put your list. So what random.choice does is it takes a random item out of your list. And when that item gets taken out of that list right here, well, then it's going to be put into the variable self.nextAction. And then when we go ahead and return that self.next action, our robot will take that action. So each time the board updates, basically this function gets called and a new action hopefully will get selected. Sometimes it'll randomly choose 2 actions that are the same in a row. So let's go back to main and run it and see what we've got. So left, right, zap, left, left, right. So it's choosing these things randomly. You'll see the zap is like a little laser beam. If I slow it down, it's a little bit easier to see. Maybe it'll do it here in a second. But it's just moving randomly around the board. Yep, you see the little laser beam there. So we've got it choosing a random action. And this could theoretically eventually collect all the flags, but it's pretty bad at it and it would take a very, very long time. So your goal is to write a smarter robot. Now, to make that possible, you're going to need to be able to detect the obstacles that are on the board. So let's see how you can do that. Now, the first thing I want to do to collect my flags is I want to get a list of the flags that I need. And this is a good way to do that, this line of code right here. Now, again, I'm just creating a variable at the start, current flag. I could just call this X or whatever I want to name it. I want to name it current flag. It's my current goal that I'm headed towards. And I get it by calling a function that belongs to the robot. That's what the self means, is it means I have this function in my own code, me as the robot. And it's called getNextFlag. And I need to pass it all the possible flags that are on the map. But thankfully I have access to that because this choseAction function gets as one of its arguments a list of flags. So I'm going to start with the current flag function right here. And that's going to give me, I'm going to start with the getNextFlag function. And that's going to give me the flag that I'm going to head towards next. And now I can start being smart as the robot. I'm using me as the robot throughout this. And to do that, I'm going to use flagAhead. What flagAhead does, if you pass it a flag, is it returns true if moving forward would get you closer to the current flag. And it returns false if moving forward would not get you closer to the current flag. So for example, really obvious way to use this would be to say if self.flagAhead, so if moving forward would be a good idea, then let's set our next action to be moving forward. And else we're going to turn left. It's not going to be a very smart robot, but it will hopefully generally move towards the flags now. So let's actually go ahead and run that and see what happens. Reminder, don't run robot student. Go back to main and then run main. So moving ahead will move me closer to a red flag, and then it won't. So I'll start turning, and then moving closer will move me to a flag. Now, then moving forward into the pit would have moved me closer to one of these flags, but I'm not detecting pits, right? It's just, hey, would moving forward move me closer to my flag? Great, I'm going to do it. Now, it looks like the yellow one is my next flag. It's not necessarily going to go to the next closest flag. It's just going to pick whichever one's next in the list. And this is actually not the dumbest robot, right? It does fall directly into holes because it doesn't check to see if there's an obstacle there. But it works pretty well. And this one's actually going to collect all the flags. And you'll notice the game just closes once it collects all the flags. All right, so that works pretty well. There are some other functions that you can also use that are going to be handy. We'll get into detecting obstacles in a second, but I just want you to know that besides flagAhead, there is also flagLeft, flagRight, and I think flagBehind. Yes, there is a flagBehind as well. So we could say elif self.flag. Oh, and you'll see the autocomplete right here, right? FlagAhead, flagBehind, flagLeft, flagRight. Now, flags and flags I need are variables. Like, don't worry about those, right? So we're not going to mess with those. We're just going to use these first four, which are functions. Sorry, flags I need is actually a function itself, but you won't need to use it. So self.flagRight. So what this is saying is if moving to the right would bring me closer to the flag, then return true, and else return false. So I could say elif self.flagRight, and then tell my robot to turn right. Now, this function is not saying that turning right is a good idea. It's saying if I could just like sidestep to the right as the robot, that would bring me closer to the flag. Okay, so it's not necessarily saying that turning right is a good idea. If you're on a conveyor, the conveyor is going to move you while you're turning, and that might cause you to end up in the wrong spot. So you have to be careful, you the programmer have to be careful about how you're going to put these together. But this is just a demonstration of how you might use flag right. So we'll run that briefly and see if we're any better at collecting the flags. Our robot might be a little bit faster. So here it's probably going to detect that moving to the right is a good idea, and it does, and then it goes down and gets that flag. So that was a little more efficient than last time, because last time it got here and it sort of spun to the left 3 times before it could move forward. Now, it's not going to be great here. It's still going to move right into the hole. Yep, and it just teleports back to its checkpoint. So it is eventually going to get all the flags, but it's still pretty dumb because it doesn't detect these holes. So seems reasonable. Next, we should detect holes in walls. So there's 2 functions that are going to help you avoid obstacles. And those functions are self.wallAhead and self.holeAhead. So very much like flag left, flag right, flag ahead, flag behind, these are going to return true or false. So typically you're going to use them like if self.wallAhead, then, I don't know, maybe you want to turn right to get away from that wall, right? Something like that. Similarly here, if there's a hole ahead, just for variety, maybe we'll turn left when that happens. Okay? So these are basically how you're going to use these functions, but there's some trickiness to this. So for example, suppose I keep this code that I had before, where I'm detecting which is best, forward, left, right, etc. Suppose that instead of having this elif right here for turning right, I'm going to have an elif for avoiding the wall. So I'm going to make this an elif, or sorry, I meant the hole. Let's get rid of the wall code for now. So I'm just cutting and pasting here. So now my robot says, if moving ahead brings me closer to my flag, then move ahead. Elif, there's a hole ahead, then turn left. Otherwise, also turn left. Let's see what happens here. Oh, and then I just made the mistake that I keep warning you against. If you're in Robot Student and you press to run the program, nothing will happen. You have to go to main and then press run. Okay, so my robot's moving, moving, moving. It's turning left, turning left, turning left. It's moving, moving, moving. And it falls in the hole. Why does it fall in the hole? Well, it fell in the hole because the order that you put your code in is really important. Right? The fact that, so going back to Robot Student, I check this first. I check, would moving ahead bring me closer to the flag? And if it does, do that. And because of how elif and else works, I skip all these other things. What I'd really like to do is first prioritize avoiding holes. Right? So I might want to put this as the if statement, and maybe I'll only move ahead if moving ahead's a good idea. So all I did was cut and paste there. So I moved if the hole's ahead, turn left. Otherwise, check and see if moving ahead is a good idea for the flag. If it is, do that. Otherwise, turn left. Okay, so it gets to here. It's going to turn left 3 times. Not the most efficient robot. You could write a better one. And then it's going to move forward. Now, hopefully it's going to check that there's a hole here before it moves. It does, and it tries to turn left. And then it moves forward. Great, we've avoided this hole. This is exactly what we wanted to do. This is much better than the first time. Now, it's still inefficient about turning left, but it's a little bit better than it was before. So now it's going to go collect the yellow flag. It's going to keep moving forward, because that brings it closer to these. Then it's going to turn left all the way around, slowly, slowly, slowly. And then it's going to move forward and move forward. And it's going to check that there's a hole there, and instead it's going to move left. But then it moves left again, and then again, and then again. And then it's going to move left again. Now it's stuck. Why is it stuck in this loop? It's stuck in this loop because if it sees a hole ahead of it, it decides to turn left. But moving forward in this case, down to this cell below it, would not bring it closer to the flag. It would actually put it further away. So it doesn't have any good code that tells it, oh, hey, sometimes you have to move further away from the flag in order to get around an obstacle. So that's a little bit frustrating. Part of the challenge of this project is for you to figure out what sort of code would you need to write so that you could move around obstacles, even if it takes you temporarily further away from a flag. And that's a big challenge in this. Here's my first tip for how to get around holes, get around walls. One thing that you might try, and there are lots of different solutions. This is just one thing to attempt. It's possible to tell your robot to take a sequence of actions all in a row without bothering with like what the other instructions are in your code. So let me show you how to do that. Okay, so suppose you want to take a sequence of actions. Suppose maybe you detect that there's a wall or a hole ahead. Let's go with the hole example so we know this will work on that map that we were just looking at. So we know there's a hole ahead. Suppose what we would like to try is we would like to not only turn left, but then we'd like to move forward once and then turn back to the right. So we're going to turn left, we're going to move forward, and we're going to turn right. And we hope that that's going to take us out of the way of the hole, just as an example. Well, the way to do that is self.add next action. So we're basically going to tell this robot, hey, your next action should be whatever we put inside the parentheses here. Now I say that that's going to be your next action. That's going to actually follow the action that you set this variable to. So the very first thing we'll do is we'll turn left, and then I'll say we're going to add the next action where we move forward. And then after that, we're going to add the next action where we turn back to the right. So we're facing the same direction we were facing before. So add next action, assuming that you add another piece of code that I'm about to tell you about. We'll basically say after your current action, and like this is actually going to be your current action, whatever you set this variable to. So in this case, left. Then you're going to move ahead, and then you're going to turn right. And you can put any sequence in you want. You just have to keep calling this and adding, you could move ahead a couple times if you wanted. But for this to work, you have to add one more piece of code. And I'm going to cut and paste it in. So that piece of code that you need in order to actually use those next actions that you've added are these two lines of code right here. So the first one is if self.has pre-selected action. So it's basically saying, hey, if on a previous move you told if the program told the robot, hey, you should do these actions next, then there's some actions that you want to get. And the actions that you want to get, and I'll scroll over to the right so you can see this, are going to be gotten with get pre-selected action. So basically this function right here is just going to grab out the next action that's in your list, and then it's going to delete it so it'll move on to the one after that. So all you have to do is say self.nextAction equals self.get pre-selected action. However, you have to be careful with your if and elif statements. If I run the code just as is, here's what's going to happen. So if I have any pre-selected actions, I'll do them, but I don't. So I'm going to go into this code here. If there's a hole ahead, then I'll do this. But at first, there's not going to be a hole ahead. Robot's going to do other things. Eventually, it runs into a hole. Then this code gets run. So my next action will be a turn to the left. I'll add these two next actions, and then I'll be done with my move. Then on the next round, when the game updates, I'll go back to choose action. And I'm going to start at the top, and I'll say if there's a pre-selected action, and there is, right? Hopefully it'll be the move that I just put in. Then I'm going to put that in self.nextAction. I'll check my flags again. And then I'll check these three conditions, this if, this elif, and this else, and I'll end up resetting next action, right? I'll erase the value of the variable that I put in right here. Because remember, if I have an if right here, this might occur, but then if I have an if, an elif, and an else, one of these will definitely occur when I run my code. And I don't want my next action erased. So probably I should make this an elif, so that now it'll do this if, or it will do this elif, or it will do this elif, or it will do this else. But again, there's trickiness here. There's this error. I hope you can see the red line on the video, because my indentation is all bad, because this line of code's not indented. I need to actually cut this out and put it before the other code. Right, so now I've got my flags. I may or may not use them, but I've got them. I'm going to check if there's any pre-selected actions. I'm going to perform those actions, that'll be my next action. And if that is true, if there are pre-selected actions, I'll say that's my next action, set next action equal to get pre-selected action. And then I'm going to skip the elif, and the else, and I'm going to return that next action there. So let's see how the robot runs with these new modifications. So it moves forward as before. It detects that moving forward is no longer any good, turns left until moving forward is good again. Now it's going to detect that there's a hole in front, and it should add a sequence turning left, moving, and turning back to the right. So that was the sequence that it performed when it detected a hole, and it ended up moving down here. It's got the next flag. Now this hole will be the real challenge to make sure it avoids this obstacle right here. So it should detect that there's a hole, turn left, move forward, and then turn right again. And it did it. And now moving forward should be a good idea. And it'll turn left around in circles to reach the flag right here. And it succeeds. Now, of course, if we go to the very challenging level that's been built and run it, it's probably not going to fare quite so well. It might get the first flag here. But I suspect it's going to run into some trouble after that. And this conveyor belt right here is usually what causes the trouble. And it falls off the end, unfortunately, and it gets reset back to this checkpoint. And that's going to happen pretty much every time. It's going to come down here, and once it moves onto the conveyor at this location, it gets conveyed to the right, moves forward, it gets conveyed to the right, moves forward, gets conveyed forward, and it very quickly gets run off the end of the board before it can step off of the conveyor. Okay, so how are you going to deal with these more complicated maps like this one? Well, there's a whole bunch of other functions that I haven't told you about that I'm going to explain right now, and I'll put in a very, very small demo of the code, not really a demonstration even. I'm just going to write down the code to show you what it looks like, but I'm not going to run it. You'll have to investigate that and figure it out on your own. So there's a lot of things that you can do with rows and columns. So your robot always has a location on the board. If you type in self.row, or rather if you print out self.row, you'll see a printout at the bottom here of what row your robot is currently in. And you can also print out the column, just abbreviated as COL. Now how you might use that, well, for example, there's a function called self.getCellInDirectionCoordinates. So this, again, you can pass things like north, south, east, or west. And if you say row, col equals self.getCellInDirectionCoordinates, it's going to give you the numeric value. So row is going to be a number, col is going to be a number, right? We could print those out. It's going to give you a row and column that is the numeric values in the direction that you're facing, that you've given it, not that you're facing, like east, for example. So it doesn't change your robot's row and column, and you shouldn't change your robot's row and column other than self.nextAction equals move. But you can get access to those values using the getCellInDirection function. So another thing you can do is you can check what is the type of the cell ahead of you, such as a wall or a hole or a checkpoint or an empty space. So if you say T for type equals self.getCellAheadType, and you pass it the board, so just like this, and then you can compare things. You can say, like, if T equals check, and I know this is not how you spell check, but it's how I abbreviated it for the board, then you can run some code that responds to if there's a checkpoint ahead of you. There's lots of different types of tiles, and you can find those tiles. You can find a whole big list of tiles in the functions.py file, particularly in a function called constructMap. So empt is the empty tile. That's the standard tile. That is not a hole. That's different. Hole is for the whole tile. There's lots of different wall tiles. Notice there's a blank space in this to make it 4 letters long. It's important that they're all the same length. There's a whole bunch of tiles listed here. And you might be wondering, okay, well, what is this over here? Why is there a colon there? We're not going to get into this. This is a dictionary. This is going to be a programming 2 concept that we worry about there. But these are the images that you can actually find in the tiles folder. So you'll notice there's a whole bunch of tiles that I used to create the map right in here. There's a whole bunch that I don't even use. You can even have your board have lasers in it as an obstacle, but I've not included any of those. There's like conveyors that convey you twice in a direction, like very swiftly. All kinds of tiles right here. Which brings me to another point is, if you would like to make your own map, that is something that you should do. And I'm going to give you some points for doing that if you make a good map. So for example, right in here, sorry, let me do that again. If you go into the maps folder right here in your folder, then you'll find the levels that I've created. And if you open one up, you'll see that it's just a bunch of names of tiles separated by commas, right? So if I go back to the code, the names of the tiles are right here, and I separate them by commas. They must always be rectangular. You must have the same number of tiles in each row that you create. But you can make the rectangle different dimensions as you like. So you might experiment with that and with creating your own map. So suppose you create your own map. I'm just going to make a copy of one of these, and I'm going to call it neilmap.txt. So you create your own map, you name it whatever you name it. You are going to have to make one more change to actually be able to access your map. So you should go into functions.py, and up near the top, there's kind of a messy function named createLevel right here. And you'll see it says like if level num equals -1, and then it has all kinds of stuff here. So you should go scroll slowly to the bottom of this file, and where it says elif level num equals 3. And then basically what you're going to do is you're going to copy the last elif and paste it in. Make sure the level number is a higher number, like 4, for example. And then what you have here is a list of pairs of coordinates. So again, a list uses these square brackets. The coordinates are in parentheses. This is a row. This is a column. This is telling the level where to put the flags. So you can experiment with these numbers. I'm just going to leave them as they are. You can experiment with these numbers to figure out where you want your flags placed on your board that you created. Then there's another list called player starts. It is again a list, square bracket, of pairs of numbers in parentheses here, a row and a column. And this is where the players are going to start. And you can have more than one player. And so you might want to put, so this one has up to 5 players that can be put on this map. And then finally, this return line, the only part of this return line that you should change is the part right after the prefix. So it says prefix plus maps slash, and you should put the name of your map right here. So I called mine neilmap. And now I have another map at number 4 right here. So finally, if I go back into main and I put the level number at 4, it's going to be the new map that I just created. So suppose you want to put multiple robots on the board at the same time and see, who can get to the flags fastest. Well, the way to do that is to go to main, and if you scroll down, actually you probably search for it, you'll see player 1 equals robot student.studentBot, and then surface and blue and the name student right here. And then there's a player list, and currently the player list just has player 1 in it. So what you want to do if you want to create a second player or third player is copy the line with player 1, paste it, change the variable to player 2, for example. Change the color. I'm just going to change this robot to red for now. There's a few colors available. And you can change the names. I'm just going to be boring and call them student 1 and student 2, but you can put your name in and your friend's name in and see whose robot is best. And then player 2, you also need to add to the list right here. So now if I go ahead and run main, you will see that there are 2 robots. There's a red robot and a blue robot. So there's my 2 robots, and they take turns moving. And since they had a different starting position, different things are going to happen to these 2 robots, right? They're going to have different luck with getting towards the flags. And so the blue one got there first. They're running the same code though, so they're both going to get stuck on this conveyor. Notice though that they can't actually shove each other. The red robot there did actually shove the blue robot downward. It pushed it. So if one robot is moving into a location that another robot occupies, that occupying robot will be pushed out of the way. So suppose you get to a point where you've written instructions for a robot and your friend has written instructions for a robot, and you want to see whose robot is the best. The way you want to do that is you should take your robot student code. You should email it to each other, basically, so you can both run the game with your competing robots. And then and then you'll each change the name of either your own robot file or the other person's. I'm going to show you an example of what I mean. So I'm going to minimize PyScripter. So I've got two folders here that both have this Robo Rally code. So here's the one I was working in before, right? I've got my robot student file right there. And over here, I've got other robot files. So I'm going to drag and drop, or I'm going to copy and paste rather, robot AI from the right one to the left. So now I've got this new robot file called robot AI right here. And what I'm going to need to do is I'm going to need to import this in main. Now I'll open it up first. So robot AI, the class is named AI1. So I go into main, and the first thing I need to do is you'll see this long import statement at the top, and it ends with robot student. So go to the end, hit comma, and then put in the name of your friend's renamed robot student file. So like I named mine robot AI1, and I don't have to put .py on it. Like don't put .py on it, right? Just put the name of the file without the .py, and these are separated by commas. So once you've got that in, you should go down to player. So player 1 and player 2, right? I showed this with the two student bots that use the same code, but now instead of them both being robot student, one of them is going to be robot AI1. Now I also have to change the student bot part if the class is named differently. Now it might not be named differently for whoever you're competing against. They might have kept theirs named as student bot, but I changed mine to AI1, so I'm going to change that in main as well. So now my red robot, who I'm just going to name it something different, name it AI1. So my red robot should now be running a different program than my blue robot when I run this code, right? And again, we make sure both of them are in the player list right here. Okay, so let's run it and see what happens. So already these two robots are choosing different code. So reminder, my blue robot is the AI one, and the red one is the robot that I wrote, that I demoed here. And I made some changes to it, so it's also not working very well. It's not detecting this conveyor, and it's getting very stuck on it. The blue robot's doing okay so far. Oh, the red pushed it to the side. That might cause some trouble. Let's see if the blue one can get off the conveyor belt. It does not look like it can. Too late. It gets set back to its checkpoint. But in any case, you can see that the two robots have different behaviors, and we can see who wins if either of them ever complete it. I'm not actually going to go through and show you every single function that the robot has available to it. Most of them are pretty advanced, and the ones that I did show you are the ones that are going to be sufficient for most maps. Now, I will point out that that level 2 map that I created is very difficult. It's a very challenging one. There could be easily more intermediate maps that I have not created, but I would challenge you to create an intermediate map of your own. But one function that I want to show you is called simulate move sequence. And you would call it like self.simulate move sequence. You pass it the board, and then you pass it something right here that I'm going to show you how to create. This is going to return a row and a column, and we should capture those in variables like this. What moves needs to be, this is going to be a variable, and so for example we could say moves equals, we're going to make it a list, so lists use these square brackets. I might say, I'm going to make this up, but move and then left and then move again and then right. So move is a list of actions your robot can take. And what's going to happen is this function is going to simulate this sequence of moves on the current robot, on you yourself as a robot. And then it's going to return where you ended up on the board. And this can be a really handy thing for dealing with those pesky conveyor belts, because those conveyors are going to move you independent of your own movement. So you want to know what row, what numeric row you're going to end up in from a sequence of moves? This function will help you figure that out. Same with what column you're going to end up in. And then suppose you want to use this and determine, hey, am I actually closer to the flag or am I further away from the flag after this happens? Here's how to figure that out. So there's a nice function called distance between. You don't put self dot in front of this because it does not belong to the robot. It actually belongs to the functions file. And what you want to do is you want to say, hey, is my distance to the flag actually smaller or larger than it was before I did this move? So for example, now we got to make sure we get the flag first. So I'm going to move this code up. I'm going to get the current flag, and the current flag actually has its own row and column. So here's row, here's column. Now these two variables right here that I'm highlighting in blue are my simulated location from a sequence of moves. And then I'm going to change these variables to be my current flag dot row. This is going to get the row of this flag that I'm looking for. And then similarly, I'm going to say current flag dot column. This is going to tell me, and I'll call it in a variable dist, the distance between where I end up and where this flag is. And I can compare this distance to another distance, which I might call current distance. And my current distance I'm going to calculate with this same function, but I'm going to change something about it. So instead of calculating the distance between where I'm going to end up from this sequence of moves right here, right? This is that row and column. I'm going to calculate the distance between where I am currently, self, my location, my current row, my current column, compared to that flag's row and column. I'm going to see, would I be closer? Sorry, here's the distance. Would I be closer if I did this sequence of moves? Or am I currently closer? Indicating like, is this a good sequence of moves or not? So then I would need an if statement to compare, right? If that other distance is better, smaller than my current distance, then hey, that's a good move sequence. I probably should do something other than just print it out. Maybe I want to follow that move sequence. You might think about how you can do that. So that's another handy way to get around obstacles and deal with those annoying conveyor belts. Two final functions I'm going to show you. So I'm going to delete these. So you can also check if self dot conveyor ahead. You need to pass it the board. So this will return true if there's a conveyor right in front of you. It won't tell you what type of conveyor, but it will return true if there's a conveyor right in front of you. And then you can also check if out of bounds is right ahead of you. All right, so if you're about to step out of bounds, it's very much like hole ahead or wall ahead, but you can also check out of bounds, and then you can check if there's a conveyor in front of you. And I hope that wraps it up. This is it can be a huge project, but it doesn't have to be, right? You can get away with writing a very intelligent robot using things like hole ahead, flag ahead, and just the simple next action equals left or next action equals move if you're smart and use your if and elif statements correctly.